Welcome back, students. Right now we're going to be talking about solving inequalities with addition and subtraction. The same way that we used to use properties of equality, adding the same number to both sides, or subtracting the same numbers from each side to produce equivalent equations, we can use those same properties to produce equivalent inequalities. Equivalent inequalities are going to be ones that have the exact same solutions. Okay, so if x is greater than 5, and we've got another inequality that states that x is greater than 2 plus 3, really those two inequalities are going to have the exact same solutions, and therefore they would be equivalent. Here, we're going to use the addition property of inequality, which states that adding the same number to each side of an inequality will produce an equivalent inequality. Here we've got a nice true statement. -3 is less than 2. If I add a 4 to both sides are going to get bigger. However, because the -3 started out lower, even adding that 4, it is still lower. And in fact, it's the exact same amount lower that it was before. In the beginning, it was 5 lower. Here, 1 is 5 lower than a 6. The same relationship still exists. So even though we're making numbers bigger, that doesn't necessarily mean that one side is now bigger than the other where it wasn't before. The same exact relationship is going to exist. Algebraically, if A is greater than B, then if I add a C to both sides of that, so we get A plus C and B plus C, the left side is still going to be bigger because it was bigger to begin with. And they both just got larger by the same amount, by C. Now, this is going to hold true for all of the different inequality symbols. All right, so we're going to solve this inequality, find out what are all the possible solutions, and then graph it so that we can show what those solutions are. Because we've got that -6 there, we'll add a 6 to both sides. -6 plus 6 is just going to be 0. X plus 0 is just x. -10 plus 6 will be -4. This is the equivalent inequality. It has the exact same solutions as our beginning inequality. However, this is a lot more obvious as to what numbers will work. To show what numbers will work, we'll use a number line. We'll put a dot at the -4. We use a filled in dot because it says greater than or equals to. So because of that or equals to, we fill it in. -4 is also a solution. And x must be greater than the -4. So we draw a line, an arrow going in the direction of the numbers that would be greater than -4. So now we've shown with this graph all the possible solutions of that inequality. Next, the subtraction property of inequality is very much the same thing. If I subtract the same number to each side of an inequality, it will produce an equivalent inequality. And we see two examples here using numbers, that the left side was less than the right side. As I subtract a number from both sides are going to get smaller, but the left side still remains less than the right side. So it doesn't change the relationship. Same thing with the algebra. If A is greater than B, and then I subtract a C from both sides, so A is going to get smaller by C, B is going to get smaller by C. Since A started out as bigger, it's still going to be bigger. Okay, and that's going to be true for all of our inequality symbols. So if we've got y plus 8 is less than or equal to 5, to eliminate that 8 and get y alone, we're going to minus the 8 from both sides. This produces the equivalent inequality that y is less than or equal to -3. To show all the possible solutions of that, we put a dot at the -3, and it says y is less than. Now notice that the dot is filled in. That's because it's or equals to. Y is less than the -3, so we draw a line, an arrow, going in the direction of the numbers that are less than -3. All right, now this time we've got a positive 1.4, so we are going to subtract 1.4 from each side. This gives us the equivalent inequality. Negative 9.4 is less than m. And so now in order to show what all the solutions are there, we put it on the number line. We'll put a dot at negative 9.4. Notice this dot is not filled in because we cannot equal the 9.4. Negative 9.4 is not a solution here. It's where it starts, but it's not an actual solution. It is only the numbers that are greater than negative 9.4 that would be solutions. So we draw an arrow going towards all the numbers that are greater. Next, we've got a nice little word problem to show how this could be applied to different situations. We got a circuit that's going to overload at 1,800 watts of electricity. You plug in a microwave that uses 1,100 watts of electricity into that circuit. What we want to know is how many watts can you add to this circuit without overloading it? So we want to think about our variables first. Okay, what are the elements of this that we're working with? Well, we've got the watts that are already on the circuit. We got the microwave, so 1,100. We got a certain number of watts that we're going to add to the circuit, and that's what we want to know about. How many can we add? We don't know that yet, so it's X. We also know the maximum number, this number that we can't go over. It says it overloads at 1,800, so we probably shouldn't even touch 1,800. That's the point where it starts overloading. So to relate this, the watts on the circuit plus however much we add needs to be less than the max. So here's our inequality. All right, now in order to solve this, we're going to use the subtraction property of inequality and subtract a 1,100 from each side. Then we've got X is less than 700. So we need to make sure that we don't add any more than 700 watts to this circuit. That way we protect it from overloading. So in addition to the microwave oven, which of the following appliances can we plug into the circuit at the same time without overloading the circuit? So we've got different options up here. We've got a clock radio at 50. That would be less than 700. We can plug in the clock radio. The blender, also less than 700 watts. We can plug in the blender. A hot plate, if we plug a hot plate onto this circuit, we are going to overload it. So we cannot use the hot plate. The toaster, also not less than 700. So we also should not be using the toaster. So we should eliminate that answer. That's incorrect right there. So just the clock radio and the blender. Those are the only appliances we could add to this without overloading. I hope that was helpful. Good luck with your work.